Problem 3. Below atomic radius, crystal structure, electronegativity, and the most common valence are tabulated for several elements. For those that are non-metals, only atomic radii are indicated. So this is the data which has been given to us. Which of these elements would you expect to form the following with copper? A substitutional solid solution having complete solubility. A substitutional solid solution of incomplete solubility, and interstitial solid solution. Okay, so for this, for the elements to make a solid solution with other element, certain conditions must be met. So these conditions are that the atomic radius should not be different than more than plus minus 15%. Crystal structure should be same. Should have very close electronegativity, and the valency should also not differ so much. So if all these four conditions are met, then the element will fall into this substitutional solution having a complete solubility. And if, for example, just one condition is not meeting, then we may consider it to fall into this category B, substitutional solution of incomplete solubility, and otherwise it will be an interstitial, it may be considered as an interstitial solid solution. So let's look at this problem by analyzing this data which is given to us. Okay, so first we look at the atomic radius. So because we have to compare each of these elements with copper, so copper is our base case. Okay, so the atomic radius of copper is 0.1278. So for the first condition, the atomic radius of all the other elements should be checked whether these are within plus or minus 15%. So minus 15% means the radius will be 0.1278 times 0.85. So this will be equal to 0.100.1086 and the upper limit will be then 0.1278 times 1.15. It will be 0.1469. So if any of these radius value for these elements are outside of this range, that will not qualify. So in this case you can see that carbon does not qualify this condition because its atomic radius is much lower. Hydrogen does not qualify, oxygen does not qualify. Okay, so and silver does not qualify. Okay, no, silver qualifies. Yes, 0.1445. So in this case, let me put it like some other. Okay, so carbon no, hydrogen no, oxygen no, silver yes, aluminium yes, cobalt yes, chromium yes, iron yes, nickel yes, palladium yes, platinum yes, zinc yes. So from the atomic radius criteria, all the other elements given except these three non-metals qualify. So these three non-metals, there is no other property given, so their atomic radii are much smaller than the copper, so they will fall into the category C. Okay, and interstitial solid solutions. Okay, so for this is the category C. Okay, so now look at the silver. So the second condition is that crystal structure should be same. The crystal structure of copper is FCC. So silver qualifies, aluminium qualifies, cobalt not, chromium not, iron not, nickel yes, palladium yes, platinum yes, and zinc no. Okay, so some qualify, some do not qualify to have a solid solution with copper, but we need to see what uh, the other conditions first before we give our final conclusion. Okay, for the electronegativity, so the electronegativity difference must be also smaller. So here the electronegativity difference is only 0 point, only 0. Here the electronegativity difference is 0.4. Here it is 0.1, 0.3, 0.1, 0.1, and here it is 0.3, 0.3, and 0.3 also. Okay, plus or minus. So as you can see that all the electronegativity atom values over given over here have relatively small differences. So tentatively we can say that all this condition is satisfied for solid solution because the electronegativity differences are all less. Okay, for the valence in this case the condition is also that the valency must not differ too much. So its valency is 2, its valency is 1. So let's see exactly which condition is satisfied over here. This condition is not satisfied over here. Okay, so this also no, this is yes, this is no, uh, this is yes. So same valency as copper, same valency as copper, same valency as copper. So now look at for silver. So silver, 3 conditions are satisfied but 1 is not satisfied. So we will put silver in category B, a substitutional solid solution of incomplete solubility. So this will be category B. Aluminium, all is satisfied except the last one. So we will put it in category B. Cobalt, uh, all conditions are satisfied except that its structure is different. So we will put it in category B. Chromium is similar to cobalt. Chromium is similar to cobalt. Here actually 2 conditions are satisfied and 2 are not satisfied. But since chromium is also a metal, its atomic radius is much closer and the atomic valency is +3. This may be considered as a have to fall in part category B. Iron also B. Nickel, okay, so nickel is the completely similar, so nickel will fall into A. Palladium will also fall into A. Platinum will also fall into A because all conditions are satisfying, and zinc only one condition is not satisfied, so zinc will be B. Okay, so in this case you can see that we have now determined that which element will form a complete solid solution or incomplete solid solution with copper, or which one will make the interstitial solid solution. Okay, one note which we can make is that the elements such as iron and cobalt, at elevated temperature they may change their phase from HCP to FCC and from BCC to HCP as well. So at elevated temperatures cobalt and iron may form a completely soluble solid solution with copper. Okay.